Welcome back to The Explainer. So today, we're diving straight into the meticulous engineering behind custom drapery. Have you ever wondered why a perfectly measured drape just suddenly changes length? Or how top-tier workrooms actually manage to tame these really wild fabrics? Well, we're going to look at exactly how the Workroom Collective handles custom orders and honestly, break down the pretty surprising science behind your textiles.
All right, here's our roadmap for today. We're covering the custom order process, meticulous fabrication standards, understanding fabric behavior, managing stretch and shrinkage, and finally, taming heat and flaring. Let's get right into it.
Section 1, the custom order process. So, the Workroom Collective operates exclusively to the trade, and they use this highly structured 5-step progression. Designers complete a partner application, review the product design guides, prepare their COM, that's customer's own material, of course, and then submit the order with a 100% upfront payment. And actually, it's only then that the 8 to 10-week production clock finally starts ticking.
Now, the really crucial point here is that they never, ever assume a fabric arriving from a mill is flawless. You just can't. Every single yard of comm is inspected immediately upon arrival. They act as this ultimate gatekeeper for quality, right? Catching dye lot variations, flaws, or missing yarns right away. Production strictly begins only after the correct, fully approved fabric is literally in their hands.
Moving on to Section 2, meticulous fabrication standards. Okay, so look at these details. This shows us exactly what engineering a drape actually looks like. We're talking 4-inch double bottom hems, 1.5-inch double side hems, top-down pattern matching, perfectly serged seams using exclusively color-matched cotton thread, and boneats ends on all panels. These aren't just arbitrary aesthetic choices. They are heavy-duty, structural standards deliberately designed to weigh that fabric down and literally force it into a tailored, perfectly controlled shape. But there are absolute physical limits to this architecture, for sure. If you're an interior designer calculating yardage, you have got to keep these triggers in mind. Pushing a length beyond 144 inches or a width over 200 inches, that's going to trigger some surcharges. The absolute maximums are 260 inches for length and 200 for width. Plus, overlaps and returns are standardized at exactly 3.5 inches to guarantee a clean, professional closure every single time. No guesswork there.
This layered breakdown right here is honestly one of my favorite details because it reveals the invisible architecture behind a beautiful drape. Notice how the hems are meticulously staggered. You have the face fabric as the primary visual layer, then the lining, which gets a 2-inch bottom hem and hangs exactly 1 inch shorter than the face fabric. Add an inner lining for fullness or insulation, that gets a serged bottom edge and falls precisely 2 inches above the face fabric. Staggering these layers is absolutely vital. It entirely prevents that bottom-heavy bulk and ensures a super smooth, graceful drop all the way to the floor.
Section 3, understanding fabric behavior. All right, this is the million-dollar question, isn't it? Why do fabrics just stretch and shrink seemingly on their own? It is incredibly frustrating when a perfectly measured drape, meticulously sewn, suddenly hovers an inch above the floor a month later. It's like there's a poltergeist in the living room. To understand why this happens without anyone even touching it, we really have to look at the science of the fibers. It all begins with something called stress relaxation. Think about the sheer mechanical violence a yarn goes through at a textile mill. It's pulled, twisted, spun, and tightly woven under immense pressure. Over time, and especially when it's finally hung vertically and fighting gravity, those yarns literally relax from all that tension they endured. This release of longitudinal and torsional stress is what causes permanent changes to the fabric's length. Because of this, the Workroom Collective provides a really vital disclaimer, noting that these characteristics are inherent to custom textiles. They are not flaws. We need to reframe our expectations entirely here. When a hand-woven silk stretches or a linen blend fluctuates in a humid room, these aren't manufacturing errors or workroom mistakes. They are simply the expected, totally natural behaviors of a breathing, living textile that's just adapting to its environment. Which brings us to Section 4, managing stretch and shrinkage. Okay, this number, 2 to 3%, this is your baseline. A 2 to 3% change in length is considered entirely reasonable in the window covering industry. As fabrics absorb atmospheric moisture and breathe with the changing seasons, they are naturally going to shrink or stretch. Just to put that into perspective, for a 100-inch drape, that is a fluctuation of 2 to 3 full inches. A really fascinating concept to understand here is diametrical swelling. When natural fibers like cotton absorb high humidity, they literally swell outwards.
And as the fiber gets fatter in diameter, it pulls the actual length of the yarn shorter. The kicker? Even when it dries out, the shrinkage never fully reverses because the yarns lock into an increased crimp. So the fabric is structurally changing itself based purely on the moisture in the air. Wild, right? And this is exactly why you must know your fabric type before you specify a design. Woven fabrics feature these tight, interlocking grids that offer controlled stretch and strong recovery. They basically fight back against deformation. Knitted fabrics, on the other hand, have an inherently looped, elastic structure. They stretch beautifully, sure, but they pose significant challenges when it comes to recovery and growth. A loose knit casement is going to behave radically differently on a rod pulling downward under its own weight compared to, say, a tightly woven cotton duck. So to account for all this science, you've got to calculate these hard industry tolerances into your designs from day one. You can expect a general fabric give of up to 1.5 inches. Knits and casements, they might vary by an inch or more. And pattern bow and bias can shift anywhere from 1.5 to 2 inches. The golden rule here for handling these characteristics is to allow sufficient fabric in those deep 4-inch bottom hems for later adjustments once gravity and moisture inevitably take hold. At our final section, Section 5, Taming Heat and Flaring. Okay, so if you place a beautifully tailored drapery panel directly over a blasting hot air duct or a baseboard heater, you are literally asking for trouble. Synthetics like polyester and acrylic and even natural linens are highly sensitive to heat. That localized blast will basically cook the fibers, causing severe reactions like puckering, warping, and shrinking. It's so intense that workrooms often have to use a cool iron during fabrication just to prevent this damage right off the bat. And definitely think twice before aggressively steaming heat-sensitive fabrics. To understand why heat is so incredibly destructive in a home, we have to look back at the mill. During commercial production, intense industrial heat, often around 190 degrees Celsius, is used to heat set and stabilize fabrics, locking those desired properties and fibers into place. When you expose that fabric to erratic, unpredictable heating in a living room or hit it with a hot steamer, you risk completely reversing that stability and reactivating the fibers. Now, synthetics are particularly notorious for reacting adversely to atmospheric conditions. This includes a phenomenon called flaring, where the bottom returns of the drape just stubbornly fan outwards instead of hanging straight down. But remember, this is a natural characteristic, not a defect. To combat this synthetic flare, expert workrooms employ a really clever, specialized technique called seam slitting during fabrication to physically release that built-up tension in the fibers. And as a quick aside, if you're using hand-woven silks, beware of sunlight, as they often stretch and actually disintegrate in direct sun. When you look at the data here, you can see that the shrinkage behavior of horizontal weft yarns is just incredibly complex. The chemical and physical processing routes a textile undergoes, from pre-treatment to mercerization to final finishing, they drastically alter its ultimate shrinkage behavior long before it ever reaches the workroom's cutting table. But despite all this wild, unpredictable chemistry, the physics, the heat sensitivity of these fabrics, the journey ends with total, pristine control. The Workroom Collective ensures their flawless engineering is preserved in transit. They do this by meticulously fan-folding or flat-folding if required, labeling every piece with size, room tag, and side mark, encasing them entirely in plastic tubing, and finally, carefully packing them in specially designed drapery boxes. By really understanding the deep science behind the stitches, you don't have to be afraid of how these textiles behave. Instead, you can confidently set client expectations and truly master the beautiful unpredictability of custom drapery. So, next time you see a fabric stretch or a synthetic flare, you'll know exactly what's happening on a microscopic level. It begs the question, what unpredictable fabric flaw will you reframe as a unique inherent characteristic in your next design project? Thanks for joining me on this explainer, and keep exploring.